most chemical reactions take place in the aqueous solution environment. All the reactions in living things are taking place in an aqueous solution environment. So anything you talk about in biology is in an aqueous world. So solutions don't have to be aqueous, but many of them are. I wonder if anyone knows like what a true definition of a solution would be. Ben? Ben says when a solid and a liquid are mixed to the point of homogenization, good catch, two substances. Because sometimes you can mix two liquids. What? Right, or even two solids coming together. So solution when two substances are mixed to the point of homogenization. I like that. How would you know when the point of homogenization is reached? What? It looks the same, right? So, and what's another word for homogenization of a solution? A shorter word. Uniform, but in the process of making a solution. Is he? No. I'm thinking of the word dissolved, right? So we would say, you know, one part dissolved in the other. And that's our point of homogenization. Is it a chemical reaction or more like a physical change? Jackson, what do you think? We can do the example of salt and water. You dump some salt in water, you stir it up, it all looks the same. Yeah, it's physical. Why?
It's more, because you go into the, like, nothing actually is like lost or gained, it's like still the same thing.
It's still the same thing, yeah. If you let the water evaporate, you're left with water vapor and salt. So you didn't make anything new. Okay, so I want to show you a quick animation of a solution. Let's see. Okay. So we have all these various compounds, and let's start with drink mix, which could be anything, any sort of powdered substance that you would put in water and drink. Could be Kool-Aid, correct. So here we have these sliders: solute amount, solution volume, concentration. What do you think the solute is? And then just kind of observe what you see here as we're playing with the sliders. Jada?
I think it's the powder.
Yes. So in this case, it would be the substance being dissolved, and the powder in this case. And then what else? We have solute and solution. So what makes the solute become a solution? Yeah, right, the solvent. And so the solvent isn't written on here, but here we're increasing the solvent. All right, now on the right-hand side, we have something called concentration. So what's concentration? Isabella?
Isn't the amount of concentration different how much the solute is dissolved?
Yes. So if we keep the solution volume constant, Isabella, how does the concentration vary with the solute?
Because it depends, like the concentration will increase if the solute is not dissolved.
Right? So, I'm going to be standing in your way. But as we put more solute in, we see the concentration increasing. So those have a direct relationship with one another. When I teach solutions, students often have a really hard time with the word concentration. But that's That's sort of the whole importance of a solution. That's what tells you the difference between this kind of solution and this kind of solution, because they're not the same. What's a way you could explain concentration to someone who doesn't know chemistry, or like a grandmother or something like that? Tom?
Does it have a ratio between how much mix we put in and the volume?
Yes, good, a ratio. So you can think about it as their proportional relationship, their ratio. What else? Even a more kind of qualitative way to explain it to just someone who doesn't study science. Yeah, Ben?
Concentration is, it's most easily seen as the difference in color, so like.
Yeah, good.
Easier to put in more flavor, yeah.
Yep. Good. So let me pull up this, well, actually I don't want to do that one. This one in color. So as we get more concentrated, the color is brighter. How else would you be able to describe it? Yeah.
Maybe how close the particles, the thing that's being dissolved, and how close they are to each other.
Yes. The proximity of the particles together. Another way you could think about it is the strength of the solution. So this is a strong solution. And actually ignore the little bits in the bottom. That's a strong solution. That's a weak solution. There's just not as much of a solute in there. If we come back to the drink mix, if you were blindfolded, how could you tell the difference between concentrated and less concentrated? John?
Well, the flavor would be different.
Right. It'll have a
Yeah,
strong
sweet.
flavor. It'll be sweet, yeah. What if you left this in the sun and the solvent evaporated? What would happen to the concentration? Yeah, it would get more concentrated.
Oh, we're gonna pour fruit punch in.
Fruit punch Kool-Aid.
Okay.
That's the solute.
Okay.
First, we have to tear the scale because the cup weighs a certain amount.
Okay. So you have to measure the weight of the cup, basically.
Yeah.
Okay.
We have to measure the cup, then the cup with the fruit punch in it,
Okay.
and we're gonna put a lot, and it's gonna be so much that
It's okay.
there'll be a little bit like it'll
Okay.
be saturated.
All right.
Much more than that.
So
From like 9.1 to 9.1.
3.87.
wait, let me see if this works.
Well,
Okay. But did you get the weight?
Yeah.
Alright. So I'll bring this. Wait, Brian, if you don't mind.
okay, great.
A little bit. It smells good. So that's how much it weighs.
That's in grams, I assume, right?
Yeah.
Yeah. Okay.
Okay, and
That's it.
that's it. And now
What is the next step you guys gonna do?
We're gonna pour it in the water
Okay.
and
we'll find out the volume of the solution.
Okay. Cool. We up to over here.
We are tasting our Kool-Aid to see if it's concentrated or dilute.
Okay. And by tasting it, you could sense what?
If it's really watery and we don't taste the fruit punch,
Uh huh.
then it's diluted.
Okay.
If it's like a lot of flavor.
A lot of flavor. Concentrated. Okay. What's the result? Okay. Step are you guys up to over here?
We're up to getting the volume of the solution.
Volume of solution. Okay.
We don't exactly know how to do that.
Can you explain to me how that process works?
What process?
Processifying whatever you just said.
Okay. Volume. Well, what we did just right now before that was we took. This isn't ours, but we took
Okay.
grape Kool-Aid,
Right.
and then we had to fill it in here, and then we had to mass a cup, and then after we massed the cup, we poured the solute into the cup, and then we massed it all together, and then we minused whatever the cup weighed from how much the total of
Right.
both were.
Okay.
And then that's how we got that.
Gotcha.
And now we're still trying to do that.
All right. Sounds good.
This up all the way,
Uh-huh.
so we can get 500 milliliters.
Okay.
And that would give us the volume.
Okay.
And then we'll try to find
Concentration.
concentration or the mass percent.
Okay. All right. So, Jem, explain to me what are you doing right now?
We just poured a ton of punch powder into water.
47 grams.
All right. And what was the purpose of that? What are you trying to figure out right now?
How concentrated this Kool-Aid is.
Okay. And how will you resolve the answer?
We'll find the volume of the solution
Okay.
and use the mass of the solute and figure it out.
All right. Sounds good.